and I also love the title of this paper because it is very understandable.
Fast radio bursts trigger aftershocks resembling earthquakes, but not solar flares.
There you go.
Done.
Oh, yeah.
It's like
perfect.
Your conclusion statement and your title.
And it's in words that people understand. And
That's amazing.
Yeah. All right.
I also like things like this where probably I don't know anything about these scientists, but like I imagine that like one of them is an earthquake scientist and one of them is a neutron star scientist, and they like came together and were like, let's in the break room over some water or coffee, and we're like, let's write a paper. Yeah. I don't know if that's true, but
okay.
Like
Welcome to Walkabout the Galaxy, the ranty astronomy podcast. It's not ranty.
Sometimes it is.
Not today. Maybe.
Challenge accepted.
All right.
Buckle up.
Where the science is universal, the opinions are personal, and this episode is topless.
Oh my.
We are strange,
it is very
charm, and down the Arkoth, also known as Josh Caldwell.
Addie Dove.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. We are without Jim Cooney, Top Quark, who is on special assignment today, so you'll definitely want to check us out on YouTube and subscribe to us on all platforms, including Facebook, Instagram, and Threads. You can contact us anytime at wtg@ucf.edu with questions, suggestions, and compliments. Our stumper today, we've done things in this general area before, but not this one in particular. Certainly not with Audrey.
I think you could say that about almost anything we do a stumper on at this point.
Every now and then, something new
Way
comes up.
out of the... Yeah.
This is space travel related, long-term space travel.
Great.
You have been chosen. You have no choice.
Yay!
You have been chosen to be part of a colonization ship to a planet around another star.
Oh, okay.
So maybe it's a good news, bad news thing.
Yeah.
Right. Maybe you've been chosen because the Earth is, everybody else is maybe going to die.
I mean, also I got good genes, so maybe that's why I'm chosen.
Yeah.
Well, that could be why you're chosen, but I'm just saying that if everybody else is going to die, then it's a good thing that you were chosen.
That's true.
If not, then maybe it's not a good thing. In any event, you're going to spend the rest of your life on this spaceship.
Cool.
Okay.
We have two scenarios. In the first scenario, the spaceship is constantly accelerating.
Okay.
So that's where you're...
At 9.8 meters per second?
That's the stumper.
Oh.
What acceleration do you want it to accelerate at?
I like this. So if you did it at 9.8 meters per second, right, it would be like you're on Earth. The gravity you would feel would be like you're on Earth. So it would be fine. Because I'm assuming your acceleration vector is perpendicular to like your floor structure.
You're going to make the we'll make it that way. We won't be sadistic in the design.
Always flying to the back of the spaceship.
That's the floor.
The way it's structured is such that
maybe multiple floors.
There's multiple floors, but they're like in the direction of travel. Yeah. Right. Okay. Yeah. Got it. So if
the spacecraft is accelerating that way,
do you know what I'm going to pick? You know what I'm going to pick.
So that it's the same as the moon?
Yeah.
Okay.
It's so fun. Something around that, right? Okay. Where it's like, because not Mars. Mars is stupid.
Too big.
But like the moon, you got a little bit to stick down, but you can just bounce. You could you wouldn't maybe even need stairs. You could just hop up to the next floor.
Jump up to the next floor.
It'd be kind of fun.
You could probably just pull yourself up a pole.
Get some ropes. You'd be like in a firehouse. You'd have like ropes and poles, and it'd be super fun.
So you could just cruise. So about 1/6 G. Yeah. So you'd weigh about 1/6 what you weigh. What about you, Audrey?
Yeah.
I think I would want Earth like...
You want your full weight?
Yeah, because if I'm going to live the rest of my life on a spaceship, I want something familiar. I know it's
that's what you're choosing is your familiar thing?
Well, I can only choose one thing in this scenario. So the one thing that I'm allowed to choose, I'm going to choose to be... No,
you could bring like a teddy bear.
You could say, I will choose...
A little teddy bear.
Lunar gravity and the complete set of Friends on DVD or whatever, so that's familiar also, right? So you can have French fries and
it's an interesting thought because also, I guess 1G is a safe answer because we don't really know for your body how your body changes over time. It could be fun. What if it's not constant? What if for 5 years you're at 1G?
This brings us to scenario 2.
The next 10 years you're at Martian G, and then you slowly ramp down.
So you might
they're talking about doing things like that for missions to Mars, where you slowly change.
Right. Well, you might enjoy scenario 2 then.
Okay.
Scenario 2.
Second scenario.
Scenario 2. The spacecraft is accelerating at a very low acceleration, so you can ignore
To basically you're weightless.
But it's spinning. And it has multiple rings.
Oh, so you can pick which ring you want to be in.
You can pick which, and so obviously you can move back and forth between rings. If you're in the center, you would be weightless. If you're on the outermost ring is 1G. Okay, and
that's where you go your crops.
There are right.
That's where you're going to
For example, or you go work out. That's where
your runs,
your weight rooms are. Right. Where do you want your sleeping quarters, your cabin to be? What G level do you want to have that dialed in at?
I think 0.
Oh, really?
Yeah.
Okay.
So you get in your little sleeping bag and you
just floating. Yeah. Okay.
Yeah.
Maybe you have special sleeping quarters though for like other times. If you have like.
What are you talking about, Addie?
Well, I don't know what those. I don't know what sex
Special
is like
sleeping?
in microgravity. Because we've never really
we haven't tried that.
We haven't tried. I personally haven't, but also generally there haven't been
since
folks
you and I
who
have
have
been in
done
microgravity together, there's a certain sort of
That's true. Also, to clarify,
I just want to say something.
we haven't either.
She's like, we haven't tried that. It's like, we haven't tried that.
No. But there have been people on parabolic flights who have tested like sleeping bags for use for that kind of situation.
Really hoping that sentence was going in a different direction.
It wasn't. But so anyway, you might want additional quarters for coupling arrangements.
Yeah, I would want to test them out because I don't know how it would I don't know how sleeping would be in different gravity environments.
That's why this is a stumper,
That's why it's
Audrey.
a stumper. You just gotta pick one.
It stumped me. You did it.
Okay. There we go, I guess.
1G.
It's never happened
1G.
before.
1G. I'm really good at sleeping.
You're a really good one. You're really set in your
love
1G.
I'm so good at sleeping. I don't want to mess it up.
Spoken like somebody who's never been in microgravity. Because once
Are you bragging?
A little bit, but also
well, it's
once
working.
we've experienced the absence of gravity, you're like, wow, gravity is really a drag.
I wouldn't know.
Maybe one of these days.
Soon.
Well, today, not today. You won't know today. But
damn it.
You will learn all sorts of things today because we're going to talk about star quakes on neutron stars.
Ooh, basically the same as knowing what microgravity feels like.
The Kuiper Belt Object Arrokoth. And a lot of space news. But first, this episode of Walkabout the Galaxy is brought to you by near-Earth objects.
Careful.
Ooh.
If you've been gallivanting around the galaxy, for your next getaway, explore the many fascinating destinations close to home with a visit to a near-Earth object. Coming within at least 1.3 astronomical units of the Sun, near-Earth objects include over 32,000 asteroids and more than 100 comets. Check out the varied terrain on Comet Hartley, or make an archaeological expedition to the asteroid Eros and visit the crash site of the Near Shoemaker probe. Whether you are interested in very small potato-shaped asteroids or moderately small potato-shaped asteroids, there's a near-Earth object for you. Near-Earth objects. Once you pop, the fun don't stop.
Pringles?
Oh, yeah. Yeah, Pringles.
It is Pringles.
Yeah.
Because potatoes.
Because potatoes. Yeah.
I like the idea of doing archaeology on an asteroid.
There's this old thing there.
That's a really cool thought for future archaeologists.
Right. Yeah. A lot of space news to talk about. We were excited. We're recording this on October 12th, 2023.
Tomorrow is October 13th. Friday the 13th.
And today might have been the launch of the Psyche mission.
Shoulda, woulda, coulda.
To the asteroid Psyche.
But, psych.
Didn't happen.
That was yours.
Psych!
There we go.
Sorry.
Oh, yeah.
I was listening.
Didn't happen.
Yeah. It didn't happen.
There's some interesting weather conditions
so weird
here
today.
in the Walkabout area.
It's very like tropical stormy, but it's not a tropical storm. Like we get big bursts of rain, and it looks like it's cold out, but it's a sauna.
Right.
It's really hot.
It's like 86 and 90, 100%.
Yeah, when the wind isn't blowing, it's really still, like weirdly still.
It's very tropical
bit,
stormy.
Yeah, it is.
But I thought Psyche was originally supposed to launch last week.
Yeah.
And then that got pushed. I don't know why.
Some spacecraft issue.
Yeah, well, it got pushed because in ground testing of their engineering models of some of their maneuvering thrusters, they discovered that they overheat. It seemed kind of late in the game to have made that discovery. And these are the thrusters that the spacecraft uses
on Psyche?
on the spacecraft.
Okay.
to change its orientation. So, like, I'm pointing here to
I
take
just
a
want to
picture
clarify
of this thing.
the Psyche spacecraft, not like the rocket that they're launching on.
Correct.
Yeah.
Oh,
the spacecraft.
okay. Yeah, I was thinking the rocket.
The spacecraft.
Oh no! Sorry. Well, now I'm realizing what you're saying.
The Psyche spacecraft has its own propulsion system, and one of the things it does with that propulsion system is fire little tiny rocket motors to change its orientation.
Yep.
And it's like point over here, now point at the Earth and transmit data.
And in theory, they've tested these extensively previously.
Before putting it onto a rocket.
And they work, but they only recently apparently discovered that there was a problem when they're run at the planned thrust level that they're planning to use it.
They hadn't tested that yet.
They had. I'm sure they had, but in any event, the most recent testing uncovered a problem.
Okay.
And the solution, there is a solution, happily, which is why the spacecraft is still going to launch hopefully in the next couple of days.
They do it at a lower level?
Exactly.
Got it.
Instead of running these thrusters at 80%, they will limit them.
Were they testing them in vacuum?
I don't know the details.
Interesting.
Yeah. They will be running them at a maximum of 30%.
Oh, that's very different.
It's a big difference. And what that means is that the
quick
turns
changes.
will take longer.
Yeah.
And my experience on Cassini is that the turn time is a thing.
Yeah.
Like, it actually mattered.
Oh, really?
Yeah.
For Cassini and Psyche are two very different missions with very different mission profiles and all of that stuff. But for Cassini, sometimes it was a big deal because it would take a half an hour to rotate from target A to target B, and you're zipping by Saturn very quickly, and that half hour was really kind of a big deal. Now, Saturn, you're zipping by Saturn quickly because it's very massive. And Psyche is going to be visiting a tiny little asteroid without a bunch of moons and rings and other things to look at. So it may not be a big deal for them at all.
That we know of. Maybe there are.
Maybe it will be. Oh, man. That's really frustrating because Psyche was delayed.
Changed the software. That's why it was delayed a week.
But it's also super frustrating because it was delayed like a year.
Yeah,
because of
another
software issues.
Yeah.
Thank goodness it was, or they might not have found this engine issue, and then they might have been in deep doo-doo.
But like, how did people, man.
Yeah.
All this stuff makes me feel a lot better when I think about how many things that didn't work very well with my little CubeSat, for instance. And I'm like, well, I spent a lot less money than all of these folks have.
Very true. But now everything's perfect on Psyche.
It's
Everything is perfect, and I'm highly confident that it, with, no inside information whatsoever, but just on my own observation of NASA missions over the years and everything, that it's going to work.
It's going to work.
Yeah.
Because there are a lot of things like this that come up that like happen after launch, and we usually have found ways to work around it. Like Juno has a different orbit than it was going to because something went wrong, right?
Yeah.
And like
Lucy's
that's
solar
actually been really
array
great. Lucy's had a solar array issue.
So, and everything's fine.
But so hopefully Psyche will launch tomorrow.
If not tomorrow, the next day. It's got about a week and a half or something in this launch window. Now, if something strange happens and it can't launch for more than whatever it is, a week or 10 days, it has to wait a year.
A whole year?
What?
Yeah. Oh, wow.
Because of the
orbital.
It had to get the Earth back in the right position.
Darn it. Orbital dynamics.
And I'm saying a year, and I don't know if it's precisely a year.
Like anything more than another month or so, I feel like is a big deal.
It is a big deal.
Because it's not, it's a long-term-ish mission.
Yeah.
But a year on the grand scheme of the mission is like a large chunk of it. And it's a year that could have been spent looking at cool data and stuff.
Yeah.
Anyway, I'm also highly confident that it will launch in this launch window.
Great.
Launch vehicles, Falcon Heavy.
Yeah.
Which is a fun vehicle to see launch.
It is.
So I hope we get a chance to see that.
Maybe go out to see it.
And it's also, the Falcon series has been a pretty reliable one. So I think it's unlikely that we'll see some strange...
Why are you saying that? You're just
I'm jinxing things like that. I love to jinx things.
So yeah, it'll launch. It's going to the asteroid Psyche.
Mm-hmm.
Yes, we have ranted. This is one of many reasons why this is occasionally a ranty podcast, because we've ranted about they named their spacecraft the same name as the target.
Yeah.
And I don't have a problem with it at all.
No.
Really?
No, I think it's great.
It just is. It's really
not an acronym,
but it's confusing when you're talking about things, right? It does make it confusing.
Just say the mission Psyche, the asteroid Psyche.
Yeah, but you have to add extra words, and people don't always add those extra words. So it's confusing. Plus, the thing we were ranting about earlier, I'll rant a little bit now, is they've been doing a lot of rhetoric in the press leading up to the launch about how it's this metal asteroid.
Oh, yeah.
And we do think it's a metal asteroid, a metal type asteroid, and that it has metallic components.
Metallic component. That's
right?
Yeah.
But like they had dialed back a lot of the rhetoric about how metal it was.
Yeah.
I mean, it's super metal in terms of like being awesome.
It heavy metal?
It's super. Yes, in terms of being
Hardcore.
awesome. It just, yes, but we know that there's silicates on the surface, for instance, and a lot of the rhetoric in this last week has been like the metal surface of the asteroid. And I've just been like, that's not necessarily what we should expect. But you pointed out it'll be 6 years before we get there. People will forget about
Yeah,
this.
I think it's just like, getting people excited about it. And
I have to say, I'm very curious to see what this thing is going to look like because unlike previous missions to small bodies where it's like, okay, it's maybe going to have a funny shape or stuff like that. It's like when we go, the OSIRIS-REx mission, which just brought back samples from Bennu, it's like when I went to Bennu, it's like we didn't have close-up pictures of that. We didn't know what it looked like, but we still knew it was going to be a dark, rocky thing.
We knew it was going to be like top shape.
But it was still really alien to see it when we finally got to see it.
But this one is like, I really don't know what it may be a very alien looking surface, and by alien I mean unlike any other planetary type surface that we've seen before. Yeah. And it may not.
Yeah. It may be
might
really
just
look
like
very
Bennu.
much like any other kind of asteroid, but
how
if
big
you look
is it
at the
compared
details
to...
of the data, maybe you'll say, oh, this spot
how big
has
is it
a lot of
compared to
metals.
some of the others we've gone to?
It's a fairly big, good size asteroid.
It's pretty big, right?
Yes.
Yeah. Speaking of OREX, you mentioned
Downport's
OREX.
going to tell us in a second.
Great. You mentioned OREX. Sample return occurred a few weeks ago.
And they opened it up.
And there was a big,
they
haven't.
started.
Yeah.
Right.
So but there was a big unveiling yesterday. I missed it. There was also unveiling of the UCF space uniforms yesterday. I don't know if you saw those.
Football
jerseys.
Oh, really?
By the way,
Yeah, it was very exciting.
To clarify.
Always annual event. Very
Space
exciting.
Games.
It was a big unveiling day yesterday. But so the TAG SAM is the main sample canister from OSIRIS-REx, the TAG SAM head, and that's the touch and go sampling acquisition mechanism or something like that.
Oh, very good.
Nice.
Yeah. I'm not sure about the A. Acquisition. Yes. And so first rule of acquisition
is touch and go.
It's touch and go. We know from the mission that they got more material than they expected, because when they left the asteroid, they were like streaming material out from behind them,
and the
because
lid
they couldn't
wasn't
close
closing.
the lid all the way basically on the mechanism. So they eventually put a thing in place to keep the material in there, and so they've opened it up enough that they basically took that lid off, the exterior lid, and so they can see a bunch of material. So the pictures we see are the top of the TAG SAM that's a bunch of material that's just piled on top. So they have 1.5 grams or something of material that they've started to analyze, but they haven't even actually opened the main mechanism to see all the material that's inside there.
Yeah.
But it's very wet and carbony.
Oh, it's wet?
Yeah.
I mean, hydrated and carbony.
Yeah. Well, that makes sense because
but it's something like 4.7% carbon or something, which is pretty high.
Yeah, and a lot of water molecules.
Yeah.
I have to say, I was a little bit, I had not been paying careful enough attention to the estimates for how much material they got in the touch and go. The maximum limit for what they thought they could get, I think, was something like a couple of kilograms, 4 pounds or something like that.
I don't think so.
No, it was maybe, it was in the grams for sure.
Well, they were
everything's
the
in
mission.
the grams.
The mission's
I want
goal.
it to
The
be-
mission goal was 60
I know the
grams.
threshold was down there, but I thought that the capability of the canister, if it was sitting on your desktop and you put dirt into it, it would hold a few pounds.
Oh,
and they actually did. Originally, they were planning to spin the spacecraft after they closed the lid or whatever,
and
do a test.
Yeah.
And apparently, they were able at some point to get some kind of a estimate on how much mass.
I remember we talked about it.
It's 0.5 pound is what their estimate is, which is still far more asteroidal material that's been returned. It's still and far exceeds their thresholds and everything like that. But
they were gonna try to do that spinning thing, but then they couldn't because of the material. So then they had to,
because they couldn't close.
They did a different way of doing it. But I remember we talked about it.
Yeah, at some point they had some indications for how that thing was checking the moment of inertia of the spacecraft. So that's
First-
exciting.
First stuff back.
Now, something else is happening on Saturday, which may be happening right around the time of the Psyche launch, if it does indeed launch on Saturday.
that would
That would be super cool. Yeah, the eclipse.
Yes.
Annular.
Here it's going to be annular. Right?
Yeah, which means it happens once every annual.
I thought everywhere was.
Is it an annular?
Here it's partial.
Oh, here it's
Here it's
partial.
a
That's
partial,
right. Oh, yeah. It's an annular in the U.S.
It is an annular eclipse, which means there are locations where the moon passes directly in front of the sun as seen from the Earth.
Mm-hmm.
But
it doesn't completely
because it's a
block
little
it.
bit further away from the Earth than it sometimes is, it does not have a large enough angular size to completely block the sun.
This is one of these cosmic things, right?
Crazy.
That are so crazy. Because, like, when we get eclipses, it's because the things are passing in front of other things, right? And so, and just like the way we are at this point of time on Earth is like the right such that like the moon is the same size as the sun, basically.
Yeah, it's
in the
crazy.
sky,
It is
but it's not
crazy.
exactly the same because we do get these annular eclipses, right?
Yeah.
And it's just like I don't know.
I mean, what are the odds? Kind of, it's like if something passes in front of something else, usually it's either going to be much bigger or much smaller than
Yeah.
the thing is passing in front of.
Yeah.
And now we have this amazing thing where our one moon can just perfectly cover the disk of the sun, which is important because it has enabled all sorts of studies of the solar atmosphere, which if the moon were twice as
that's
big, you wouldn't be able to get that same kind of full picture of the solar corona just from Earth base. And it was also instrumental in the confirmation of general relativity because during a solar eclipse, the sun was blocked and you could see a star next to the sun
that was behind.
that was in the wrong position.
Yeah.
Right? And it had to be very close
Yeah.
to the sun in order for the sun's gravity to distort its path through space. However, now we have spacecraft that can go visit the sun, which is my segue to another bit of space news.
Yeah.
There's an Indian solar observatory.
PSP also recently set Parker Solar Probe also recently set a new
Speed record or
land
something.
speed record, space speed record for fastest spacecraft as it like zipped
Zipping around.
close to the sun. Continue though.
Another spacecraft heading out to observe the sun, but not getting close to it like the Parker Solar Probe, is called Aditya L1, and I probably mispronounced that. It's an Indian mission, and it's going to the L1 Lagrange point. So it'll be standing far back from the sun and just a solar
safer there.
observatory with several instruments.
What is it going to look for?
It's going to look for solar activity.
Sun things.
Oh, great.
Visible? UV? IR?
Probably,
In wavelengths of light?
I'm guessing multiple wavelengths.
Interesting.
It has 5 instruments.
Okay.
Wow.
They're going to look at the sun.
Cool.
I'm guessing that there will be spectrometer or two
There will
and
be
some
spectrometer?
and an imager or two on that thing.
Oh, cool.
That's what I'm guessing. Yes.
Are we
Space
going to
news.
bet on it?
Give me a break. Space news here. So we have two kind of main science stories. One is about Arrokoth, and one is about star quakes on neutron stars. But we had some interesting and voluminous space news, so I want to give you the trivia question now
Okay.
Because voluminous.
it is
Is it voluminous?
it's spacecraft related.
Oh.
So it ties in more with what we've just been talking about.
Okay.
And also date related, because we've been making a big deal about how today is October 12th.
And we love going on dates.
Today is the
We love dating.
Today, October 12th, is the anniversary of the first space mission with more than one person.
Say that
on
again?
board.
What?
X years ago today
was
the first mission
Sure.
to space with more than one human on board.
Sure.
Okay.
What is X equal? Okay, that's your first trivia.
Okay.
The second is when and what was the first mission to take more than 3 people into space? And then
More
there'll
than
be a
3.
follow-up. More than
Ooh.
3. And then there'll be a follow-up after that. Okay. So
They all launched together, you're saying.
3 people in one spacecraft
Launching from the Earth.
launching from the Earth. Or the first question is, What's the first
Yeah,
one?
yeah,
There
got
was
it.
more than one person in
Got
the
it,
spacecraft.
got
So
it.
Yuri
Just
Gagarin went up.
Just
John
clarifying the
Glenn
last
went up.
bit.
Then we all know there was a bunch of Apollo missions with 3 people, etc. When was the first time there was more than 3?
Got it.
Cool.
Audrey is unimpressed.
Yeah.
Okay, well, tell us about Arrokoth.
Arrokoth is really exciting. So Arrokoth is a Kuiper Belt object.
Whatever.
Whoa. Wow.
He was echoing your lack of excitement.
Yeah,
Yeah.
it does feel terrible.
Yeah, right?
Well, sometimes it's
That's what-
deserved. Just kidding. Just
Oh.
kidding. Just kidding.
Wow, this should be the.
Boy.
This could
Man.
become the aggressive podcast.
Yeah.
Oh
I was going to invite you on a 0G flight and everything.
no, I missed my chance.
You did.
Wow.
You didn't
My
miss
sass.
it. You shot it in the butt.
You can go on a 0G flight. Psych.
All right. Arrokoth is in the Kuiper Belt and it's been visited by a spacecraft.
It's been visited by the spacecraft New Horizons,
Which recently
which
had
was,
news, actually.
Yeah, it was recently, like about a year ago, they were like, so New Horizons originally it flew past Pluto.
Yes.
And then after that part of the mission, there was an extended mission to fly past the Kuiper Belt Object Arrokoth. And then after that, there was this longer study period to see, okay, what else can we do with this spacecraft?
We didn't really find any objects. It's really
Yeah.
hard to look that far out
It's
from ground-based
hard.
telescopes.
Yeah.
And we didn't really find any objects sort of in its path that it could go, because it's out in the Kuiper Belt where there's things, but they're
pretty
very
empty.
tiny and they're
Yeah.
very far apart.
It's not Empire Strikes Back asteroid belt
Yeah.
territory.
Yeah.
And after Pluto, which is arguably, people would say, okay, that's the inner edge of the Kuiper Belt in some sense.
Sure.
They had some fuel, so they had a little cone of directions that they could go in,
yeah.
and they used the Hubble Space Telescope to really do
they
a lot
did?
of long, deep exposures in that cone of space, and they found Arrokoth and
Yeah.
said, "Let's go." They said, "NASA, hey, we can send New Horizons to this thing there," and they're like, "Great, go for it," and they did, but they didn't also say, and then we can also go to this other thing after Arrokoth.
Right. Yeah,
Yeah.
they didn't. Which isn't. I mean, that's not uncommon for a mission. After the main phase of the mission, you
Yeah.
kind of have to go phase
Step by step.
Yeah, step by step. And so, from what I understand, there isn't enough fuel to change the direction to actually fly by another object. It's also really hard to find these objects, but it can still observe things in the Kuiper Belt. Just not as closely. But then about a year ago, a panel decided, or maybe not decided, recommended that the New Horizons spacecraft be kind of given to heliophysics. And
Because they're in a part of space now where, most of the interesting things that are happening have to do with particles and fields and the heliosphere and the sun. And so, it sort of made sense.
Yeah.
Sure.
I mean, and it's not
There's not a lot of
unprecedented.
geophysics to do where
but-
they are now.
And it's not unprecedented to sort of retask spacecraft.
Yeah.
And it feels like it's becoming more common now.
Yeah.
OSIRIS-REx, which we were just talking about, is now a new mission with a new mission leader.
Yeah.
Like the
PI is going to be different.
The person leading
Right.
the mission. It's still a planetary mission. It's still going to be going to an asteroid, but it's got a new name and a new mission. And
we've done
they've
this
done
with,
that with other spacecraft too.
And we've gone the other way. So, heliophysics mission Themis was studying the sun. The Themis missions spacecraft are now the Artemis A and B spacecraft that are in the sort of near lunar, or they're still in a solar orbit, but they're sort of near the moon. And so we get a lot of this really cool Artemis data. It's all capital Artemis.
Right.
That's actually previously Themis spacecraft.
I did not know that. That's
Yep.
cool.
That's really cool.
So now New Horizons has been
so, yeah, it
transferred from the planetary part of NASA to the
was going to
well,
be.
it was going to be, but
They just announced.
But yeah, the announcement is that it will not be transferred. In fact, it will stay in the planetary part, and it will continue to study Kuiper Belt objects.
Okay.
And
Our friend Alan Stern had his
strong
way.
petitioning.
Yeah.
Strong
yeah.
petitioning powers.
The PI of New Horizons, Alan Stern. Yeah. And the idea is that it'll stay a planetary mission until they get out of the Kuiper Belt, which will be in about 5 years, I
million
think.
years.
it said something like that.
So it's interesting. The Kuiper Belt, for me, I think of the Kuiper Belt as this vast expanse of space.
Yeah.
But there's a bunch of different sort of populations of objects.
Yeah.
And if you define it by the average orbit of those objects, it's not huge.
Sure.
But
like that's
there
how
will
they're
be
getting...
lots of things.
Yeah.
There's lots and lots of things beyond this
Kuiper
edge
Belt.
that you're talking about that are still Kuiper Belt objects. They're just on their sort of other parts of their orbit, and there's all these things. There's the scattered disk and the classical.
Is New Horizons at this point out of the plane of the solar system too?
Oh, I don't know.
I don't remember what its trajectory looks like.
I have no idea.
Anyway.
Yeah. Well, so that's cool. And the team, the New Horizons team, they're still doing really cool science with the stuff that they have, with the data that they've already collected. For example, Arrokoth is an extremely primordial object, which means it formed from the protoplanetary nebula and has undergone very little, if not any, post-processing. So it hasn't heated up that much. It hasn't smashed into something really big. So it's kind of it's cool little.
It's a very primordial piece of the whole puzzle.
Exactly, and the shape of Arrokoth. They have recently. So Arrokoth has these two lobes essentially that have weird lumps on them. And they thought originally...
So the thing as a whole sort of looks like a gingerbread cookie
snowman
or snowman.
Yeah.
It's sort of,
yes, exactly.
We flew by it, we didn't orbit it. So we just have kind of one aspect of it, pretty much.
Yeah.
And it looks like a big cookie and a little cookie stuck together.
Yeah, I think it's like if you kind of imagine like a I don't know, a ping pong ball and an Oreo. One of the lobes is pretty flat.
And one is more
round.
Oh,
yeah.
Okay. There was a lot of back and forth when we first flew by about that, because it was like, we just mostly have a sort of edge-on view, but they were able to get a couple of before and after views that gave us a little bit of...
Yeah.
And so,
yeah, exactly.
Yeah.
And so there are these lumps on Arrokoth that originally I think people were hypothesizing they were some kind of... they were due to like some weird cratering event or something, but what they have kind of determined is that those lumps, they look a little like raspberry, like little raspberry bumps.
Can I change the ping pong, since you're now
sure.
using raspberries and you used Oreos? The ping pong ball is really not fitting in with that food theme. I was going to say rum ball.
What's a rum ball?
Oh, rum. They're so good.
Oh, yeah.
It's
Eat them at like Christmas time.
Sure.
Get a little boozy.
A rum ball and an Oreo
and
raspberries.
And a raspberry. Or a blackberry. But yeah, like these little like lumps on it. And essentially what those are even more primordial. Yeah, they're more primordialer bits that came together to form each of the lobes.
Okay.
And
so we're really seeing the building blocks.
The actual blocks, the individual Lego pieces.
Right. And that's pretty cool.
It's so cool because there's a theory called streaming instability, which one of you might explain.
And part of the way to
streaming
explain
instability is a problem that middle-aged men have, and I don't really think that it's appropriate.
I don't know if streaming instability is ever sponsored
for the podcast.
Yeah. Well, so to take one little step back, right? So like what we're talking about is you can sort of see, it's like when you have the things that like when you have chocolate chips next to each other, for the food analogy, and they like slightly melt.
Yeah.
So you have like sort of lumps, but they have no. Or when you're cooking your chocolate chip cookies, but you have too much butter, and so they all spread out and melt together, and then they get these sort of edges. That's what we're picturing.
Yeah.
But streaming instability.
There was for a long time a lot of questions about how you made things like Arrokoth or the lumps that make Arrokoth, because gravity is so incredibly weak between raspberries or blackberries or
chocolate chips,
rum balls or Oreos, that the gravitational pull between two objects like that is not enough for them to come together and stick together. In particular because there's turbulence in the low pressure gas that surrounded the sun and that all of these particles were in the early days of the solar system. And that moved those little particles around with too much speed for gravity to allow them to coalesce. Because the suggestion was like, well, we can have what's called a generic gravitational instability where maybe two Oreos don't have enough gravity to come together, but suppose I have a gajillion Oreos get together in a big flash mob of Oreos, and collectively their gravity is enough for them to all come together into a giant, sort of Ghostbuster scale Oreo mash. Mixing my dessert metaphors there. But the turbulence of the gas prevents that. The streaming instability is a way to protect that big pile of Oreos from that turbulence, much in the same way that...
Now we're going to switch to sports metaphor instead of
the
food
lead
metaphor.
Bicyclists in the group of bicyclists protect the bicyclists behind them from the effects of the air going by. Yeah. So as these particles are moving through the protoplanetary nebula, there is an instability that can develop where they are protected.
There's like a clump of stuff
in
that's sort
the
of
lee
protected
side,
in a wake.
essentially, in the wake from that stuff, and you have a quiet space behind where gravity collectively can take over, and you can form raspberries and Arrokoth.
Interesting. Okay. That's really cool.
That's a very oversimplified description of it.
I know...
But it's making me hungry.
Yeah, I'm really hungry now. I know that one of the outcomes of streaming instability is the kind of two lobes. You can get objects that have two lobes or equal mass binaries, which there are a lot of in the Kuiper Belt. And we see a lot of them in the Trojan asteroids as well. So this new thing not only has really cool implications for what to kind of like look for within the Kuiper Belt, but also when the Lucy mission flies by its last Trojan target, Patroclus and Menoetius.
Excuse me?
Gesundheit?
Patroclus and Menoetius. I don't know if Menoetius is pronounced. I know Patroclus. Everyone says it differently, but
I would have said Patroclus probably.
Some people do say that.
Yeah.
I don't. I guess I could.
Anyway.
But it's a binary, and so that's one of the reasons why people think that the objects in Jupiter's Lagrange points, the Trojans, came from the Kuiper Belt originally because there are so many of these bimodal things. And so now when Lucy flies by it, we can look for things like this raspberry texture.
Interesting.
Yeah.
Okay. Cool. So another sort of indicator to look out for the streaming instability, in addition to a sort of general additional confirming piece of evidence that that's how the building blocks were made.
Yeah.
Also, apparently for some reason now the lobes of Arrokoth are called Wenu and Wiu.
Okay.
And I've never heard that before until I was reading this paper.
All right. Well, our last story I thought was kind of fun. It's in a very different realm now. We're talking about neutron stars and fast radio bursts.
Furbies. I like to call them Furbies.
So there's this phenomenon of high energy radio bursts that sometimes are repeating. So there have been some sources that are repeating. A lot of the fast radio bursts are extragalactic in origin. Some of them have been seen from within the Milky Way. But there are a few that repeat. Otherwise, it's like, well, these haven't been known for very long. They're just like, people were sort of pouring through some old radio data, looking at pulsars, and discovered that there were these weird sort of 1 second or shorter high energy bursts.
Yeah.
And the amount of energy, if you extrapolate it back to where it came from, is huge. It's like as much energy in 1 millisecond as the sun produces in a day, kind of. So it's a huge amount of energy. By the time it gets to Earth from frequently another galaxy, it's a very, 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 very faint radio signal. But in any event, this was a really cool paper.
It's super fun.
What the... fun. I'm speechless.
It's so funny. So this was a paper from some folks at the University of Tokyo, I think, who studied like how these sort of the shape of the signals and like how they change with time?
Yeah, they looked at the distribution in time and in energy of a bunch of repeating fast radio bursts. And they said, let's compare that to the distribution in time of energy of some other things nearby and see if there are similarities in the pattern.
So, like one thing,
Some things and two phenomena in particular they compared
So
it
one
to.
was like solar flares, which are also like sort of transient events from stars,
yeah.
where you have like a burst of material that we have these all the time from the sun that flies off, and you have energy released, and it changes with time. It can change with time. And they also compared them to earthquakes, because why not?
On Earth?
On Earth. Yeah. But this would be a case of star quakes, basically, like quakes on the surface of a star.
Right. So what they did is they said, okay, here, let's pick some object that's a source of repeating fast radio burst, right? And they look at it's like big burst, and then a couple hours later, a little burst, and then 3 days later, a big burst, and then a couple hours later, a little burst or something. And they would go, oh, there's sort of a pattern there. I'm making those numbers up completely, right? But they looked at sort of the pattern. Is there a correlation between the time between bursts and the shape or the amplitude of the bursts and things like of that nature, right? And they compared it to when the sun does things bursty, like solar flares, and then they compared it to when the Earth does things bursty, like earthquakes. Now, this wasn't just a random thing, like they're not going to compare it to the changes in the stock market, right?
Right.
Because what is producing one of the theories for what's producing a fast radio burst, they're coming from neutron stars potentially, and it's maybe something violent happening on the neutron star, like a neutron star version of an earthquake. Okay?
Which would mean that you would need to have some sort of like surface and crust on the surfaces of neutron stars.
Right. And so this is what they found.
Too?
So you'd have to have it like cracking.
Right. There have to be like moments of movement.
Yeah.
So what they found is that there is not a similarity in the pattern and distribution of the Furbies with solar activity, but there is a similarity with earthquakes.
Yeah. And this includes things like the initial burst and then like aftershocks and earthquakes where you have follow-up things that happen. Like we see similar things in some of these repeating FRBs where you have like an initial burst and then follow-up things. So.
What would cause that in a neutron star?
So
I think of them as like very, very homogeneous.
Well, I did too, and I was wrong.
Homogeneous. Well, I mean, you'd have to be for these things to exist, right?
So neutron stars have a radial structure. So I had always thought of them as like this perfect ball of neutrons. So the neutron star is formed.
Just a little perfect ball of neutrons. Is that the episode title?
It's so beautiful.
A Furby is just a perfect ball of neutrons.
The neutron star, of course, remember, is the remnant from a supernova explosion of a massive star where the core collapses because there's no more nuclear reactions to support it against its own weight.
Right.
And it collapses beyond the white dwarf limit where electron pressures against each other support something. It's too massive for that, too much weight. And so in a very naive sense, you could say, well, it collapsed down so that the protons and the electrons are smushed together and you have a ball of neutrons.
I thought that was the definition, not a naive thing.
But that's just in the core. It's only in the middle because at the surface of the neutron star...
is it a rum ball also?
There's less...
There's not as much pressure.
Yeah.
And, it's going to cool down, so you're going to get a little crusty surface?
Initially it's hot, and the surface is actually atoms on the surface. But we don't know a lot about what it's like. We don't know what the atoms are or what state they're in. And then as you drill down into the neutron star, which is small for a star type thing, it's only a mile or two across or so. Maybe it's 10 miles across. No, it's like a couple miles across. In any event, very, very dense. The surface of that neutron star is super, super smooth because if you put a little hill on it, the gravitational pull is so strong.
It'll instantly flatten out. Yeah.
So the surface structure is like
very smooth,
maximum a millimeter variation as you go around this ball.
Sure.
Right. But you can have a solid crust on that neutron star, and it can crack and have some events which would release energy, perhaps like these radio bursts.
Interesting.
Wow.
So
Cool.
I thought it was
That's
just,
Are there
amazing.
other papers that talk about like the surface structure of neutron stars? I assume.
not that I have read,
Well,
but I am
we'll
sure
have to
they
look.
exist.
We'll have to look into it more.
Yeah. So anyway, I thought it was very cool, and I also love the title of this paper because it is very understandable.
Fast radio bursts trigger aftershocks resembling earthquakes, but not solar flares.
There you go.
Done.
Oh,
It's kind
yeah.
of like,
It's like
Perfect.
your conclusion statement and your title.
and it's in
Yeah.
words that people understand. And
That's amazing.
Yeah. All right.
I also like things like this where probably I don't know anything about these scientists, but like I imagine that like one of them is an earthquake scientist and one of them is like a neutron star scientist,
Yeah.
and they like came together and were like, let's in the break room over some water or
That would
coffee,
be- that
and
would
we're
be
like,
fun.
let's write a paper.
Yeah.
I don't know if that's true, but
I like
okay.
that.
Today is the nth anniversary of the first
right.
flight of more than one person in a spacecraft at the same time. What does n equal? Or what? I don't really want to know what n equals. What year was the first flight? It was on October 12th. I'll give you a hint. 19 something.
what?
Okay. The reason why I wasn't excited about this is because I'm so bad with like dates and history
Well-
and stuff, and so it really is just going to be a crapshoot.
73.
Okay.
Which is the
73.
50th anniversary.
Now you know that's not true.
I know, but I'm having trouble remembering my exact dates right now, and it's really bothering me.
Oh, okay. All right.
1962.
Right. So we're taking first date with more than one person.
Yeah.
And you know that Neil Armstrong and company went to the moon before 1973.
I know. Should I say 60?
Well, they went in 69. And you know that before they went to the moon,
67.
64 is the answer. It was Vashkod 1.
So it's the 49th anniversary. Nope.
It's
Add 10. 59th anniversary.
59th anniversary.
Wow.
And there were 3 cosmonauts on board and no spacesuits. It was supposed to be just for 2 people, and then some politicians said no.
Throw
Put
another guy in
person
there.
in there, and to make room for that person, they had to get rid of the spacesuits.
When politicians make those decisions, it always goes well.
It's a great idea.
Did they all make it back?
They did.
Okay, great.
Yep.
Oh.
24-hour mission.
When was it? 64?
1964, October 12th. When and what was the first mission to take more than 3 people into space?
65.
No. That's what. So it was a shuttle. It had to have been a shuttle. So, but it wasn't Columbia 1 because that was only 3. It wasn't STS-1. So STS-2.
STS-1, in fact, was only 2 people.
Oh, that's
Young
right.
and Crippen.
It was Young and Crippen. Yeah.
Yeah.
STS-2.
STS-2 was also 2 people. The first 4 just had 2 people.
Oh, wow.
It was STS-5 had 4 people. Space Shuttle Columbia, that was in November of 1982.
82.
Your final bonus trivia here is the first...
I was clarifying on that earlier because, like, there were like Apollo-Soyuz dockings where
Right.
like people in
Yeah.
Apollo people, and then it would have
Right.
been more in
Right,
the
right,
vehicle, but not it was
Oh,
not launched
sneaky.
together.
That's a good clarification.
Sneaky.
The first flight with 5 people, again, would have had to have been a space shuttle mission, was STS-7, Space Shuttle Challenger.
Well, they ramped it up.
In June of 1983, this flight is famous, however, not for being the first flight with more than 4 people, but for something else. What was that flight famous for?
Which one did you say it was?
STS-7, June 1983.
Was that?
That was the one where the toilet broke. I'm just kidding.
That was
was
everyone.
That was a Brendan Byrne shout out. That was the first one with a lady.
I was going to say
You are
First
correct.
Lady.
That was Sally Ride's
Yeah.
flight to space, the first
Lady.
American woman in space. All right.
Good old lady.
Only 20 some odd years after
That's
the
right.
first American.
Good job.
While it may have felt like a high G ride through interstellar
Interstellar space.
Interstellar space. It was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all of our updates. Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jarusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Ontario, Canada. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
We're the Astroquark, signing off until the next episode of Walkabout the Galaxy.
Cypher me!